Hey there, and welcome to this explainer. Look, if you're a university student dreaming of landing your very first artificial intelligence internship at a FAANG company, Google, Meta, Amazon, or even a high-growth startup, you are in exactly the right place. Today, we're giving you the ultimate step-by-step career blueprint to transition from just learning the theory into becoming a highly capable builder. We're going to architect your career from the ground up, basically turning your academic potential into the exact engineering maturity that big tech hiring managers are actually looking for.
So we've organized this explainer into 4 highly actionable sections. 1. The AI reality check. 2. Mastering the FAANG foundations. 3. The 5-phase Python roadmap. And 4. Building to stand out. Let's jump in.
Section 1. The AI reality check. Academic theory versus big tech reality.
As a university student, it's super easy to think your internship is going to consist of sitting around theorizing about algorithms or just implementing architectures from famous papers like "Attention is all you need." But the reality of big tech, it is a highly practical, engineering-heavy role. Now sure, you'll read research papers, but your day-to-day is actually going to involve heavy data engineering. You'll be cleaning real-time API data, structuring it for training, and building the MLOps infrastructure you need to serve those models to millions of global users without the whole system crashing. Really, it's all about flawless deployment, not just the theory.
Moving on to Section 2, Mastering the FAANG Foundations, the hidden gatekeepers of big tech.
Let's be real for a second. Your mathematical foundation is absolutely critical. Calculus and linear algebra aren't just annoying university prerequisites you pass and then immediately forget, right? They are literally the languages of machine learning. You need a really high-level mathematical understanding to manipulate tensor operations. Since tensors are multidimensional data arrays, you have to know exactly when to squeeze or unsqueeze their dimensions. Plus, to correctly implement a mathematical loss function, like binary cross-entropy for classification tasks, your derivations have to be absolutely flawless.
And that mathematical rigor, it feeds directly into the coding interview itself. To survive those famously grueling FAANG interviews, blind memorization of data structures and algorithms simply won't cut it. Interviewers test your algorithmic thinking heavily. So, to truly stand out, you need to deeply understand the algorithmic execution flow. Actually, the absolute best way to prove your mastery here isn't just practicing on a whiteboard. It's building your own interactive data structures and algorithms platforms, or even coding your own C++ execution visualizers. Doing that proves you don't just know the code, you know exactly how the machine is processing it.
All right, Section 3, the 5-phase Python roadmap, from basic syntax to enterprise AI.
We put together a structurally perfect blueprint that takes you all the way through core Python, advanced engineering, the data science backbone, machine learning and deep learning, right up to production and cloud deployment. So let's break these down phase by phase.
Kicking things off with phases 1 and 2. Look, before you can train a model, you have to write clean, modular, and reusable code. That means mastering object-oriented programming, your classes, inheritance, polymorphism, the whole shebang. But you also need that advanced engineering maturity. You got to understand memory management behind the scenes and really get comfortable using iterators, generators, and decorators. Most importantly, though, you absolutely need to master asynchronous programming using async. This is non-negotiable when you're building applications that fetch real-time data simultaneously without completely blocking your program's execution.
Then we move into phase 3, the data backbone. Because let's face it, an AI is only as good as the data you feed it. You have to master the industry standards for data handling here. You'll need NumPy for incredibly fast numerical computing, you'll use pandas to clean, analyze, and wrangle massive data sets, and you'll use libraries like matplotlib and Seaborn to visualize data distributions and spot underlying trends long before you ever feed a single piece of data into a neural network.
Now, phase 4 is the core of your AI development. This is where the magic happens. You're going to start with scikit-learn as your go-to framework for classical machine learning, like linear regression and clustering. From there, you graduate to PyTorch, which is the modern industry standard for deep learning and AI research. PyTorch is exactly what you'll use to compute those complex gradients we talked about earlier, and you'll use it to build custom deep neural networks entirely from scratch. Finally, you'll want to equip yourself with Hugging Face transformers. That is your essential toolkit for leveraging cutting-edge large language models and natural language processing.
And finally, we reach phase 5, production. Honestly, this phase right here is what separates the researchers from the true engineers. Big tech companies need to know for sure that you can actually put your Python models on the web. So you'll learn to wrap your model securely into lightning-fast endpoints using Fast API. You'll integrate modern databases like Supabase or Postgres. You'll deploy via cloud platforms like Vercel or Railway. manage network traffic securely with Cloudflare, and automate that entire deployment process using GitHub Actions. That right there, that is true MLOps.
All right, our final section on the agenda, Section 4, Building to Stand Out, the end-to-end practical projects differentiator.
You know, there is just a massive gap between a typical academic assignment and a truly FANG-ready application. A basic resume project usually lives in a local Jupyter notebook, uses basic scikit-learn, has zero user interface, and relies on a static dead CSV file. But a FANG-ready project, that is a fully cloud-deployed application. It uses custom PyTorch architectures or powerful LLM APIs. It's served up to the user via a sleek, responsive front end built with React and Tailwind CSS. And most importantly, it pulls from real-time, live APIs. That is how you immediately signal your value to big tech recruiters, by proving beyond a doubt that you can build end-to-end.
So instead of just following another generic tutorial, you need to tackle real-world problems. Think about building an automated trading bot utilizing live financial APIs. That definitively proves your engineering maturity and your ability to handle asynchronous, real-time data streams. Or maybe building a real-time review system for a local emergency ambulance service. That shows you can handle complex databases and user front ends. Or even writing secure file sharing scripts to demonstrate a really deep understanding of cybersecurity permissions. These aren't just little side projects. They're highly practical, real-world applications.
So what does this all mean? The ultimate goal here is to become a T-shaped engineer. The vertical bar of the T is your deep, rigorous expertise in AI and machine learning, understanding the complex calculus, the loss functions, the tensors running under the hood. But the horizontal bar of the T is your broad software engineering skill set, your ability to build a responsive front end, manage a database, and deploy a totally secure backend. You have to be a well-rounded builder.
To wrap things up, I want to leave you with a question to really kickstart your career. The journey to becoming an AI researcher and engineer is a marathon, and building consistent, full-stack projects is hands down the fastest way to get to the finish line. So given the roadmap we just covered, what specific area of artificial intelligence, whether that's computer vision, natural language processing, or autonomous systems, are you going to conquer for your very first end-to-end project? Pick your passion, start building, and architect that dream career. Thanks for turning into this explainer, and I'll catch you next time.